Chapter 1, Assessment. Today we are going to cover chapters 1.1 through 1.4. This is the pre-assessment, and I will be going over how to do each of these problems. So the first problem says solve the equation, show your steps. You must show your steps. Got to show it. I know this is simple. I know we can look at this problem and see that the solution is 8, but I want to see the mathematical reasons on why it ends up being 8. Our objective is to isolate the variable, and we have to look and see what is happening to the variable. 4 is being added to it, so the inverse of adding 4 is subtracting 4. So that's why we subtract. We have to keep it balanced, so we're going to subtract 4 from both sides. We'll do the same for this next problem. The signs are the same, so we combine and keep the sign. So my answer is going to be negative 17.9. We'll move on. What's happening to the variable? It's being divided by 2 pi. So we will multiply both sides by 2 pi. And that gives us 2 pi times 10 is 20 pi equals x. What's happening to the variable here? It looks like it's an equivalent fraction. It is, but if we look at it through the variable, we see that it's being divided by 2. The inverse of dividing by 2 is multiplying by 2. So we're going to multiply both sides by 2. This 2 is in the numerator. This 8 is in the denominator. We can cross cancel. And we get 3/4 equals B. That's a nice, easy, efficient way. Number 5, we again have pi's. We're solving for r, so we're going to subtract 3 pi. The pi's do not cancel. That becomes 6 pi. It would cancel if we were dividing, but since we're adding and subtracting like things, we have 9 pi's. You can think of 9 pizzas, and we're subtracting 3 pi. Subtract 3 pizzas, we are left with 6 pizzas, or 6 pi. First thing we want to do is convert that to improper fractions. Probably it's going to help me, maybe even like denominators. So I can do that conversion right now. I can wait until later. Now I see that 5/10 is being subtracted, so I'll add 5/10. Add 5/10, and that gives us negative 8/10 equals x. All fractions have to be simplified, so negative 8/10 is negative 4/5. That's a horrible 4/5. Negative 4/5 equals x. That would be my solution. 3x plus 4 equals 19. Now we have 2 things happening to a variable. So we are going to get rid of subtraction first, which gives us 3x equals 15. We're going to divide both sides by 3, and that leaves us with x equals 5. We again have multiple things happening to the variable. We're going to get rid of addition and subtraction first. That's f over 4 equals negative 4. 4 is dividing by my variable. Inverse of dividing by 4 is multiplying by 4. So we're left with f equals negative 16. Number 9, this time we can't add and subtract, get rid of addition and subtraction first, because there's a vinculum. That vinculum is very important. Sort of like Chewbacca, it's a parentheses. So I can't get to that negative 7 yet. I have to get rid of this dividing 3. The inverse of dividing 3 is multiplying 3. And now that cancels, and that leaves me with q minus 7 equals 24. We're going to add 7, and we get q equals 31. Here we have multiple things happening on one of the sides of the equation. So we are going to simplify first. Simplify like terms. And 9z minus 4z gives me 5z minus 5 equals negative 5. Now there are two things happening to the variable. We're going to get rid of addition and subtraction. 5z equals 0. Divide by 5. Divide by 5. Z equals 0. 0 over 5 equals 0. There's two ways of doing number 11. I'm going to do the most efficient way. I can't get to this A. I can't add and subtract that 12 because Chewbacca's here. So I got to get rid of that negative 4 first. I can do it either through distribution or I can do the inverse. I'm going to do the inverse, way more efficient. That leaves me with A minus 12 equals negative 9. We're going to add 12 and we get A equals 3. We will not add 7 plus 3. We can't add before doing multiplication, etc. I'm still trying to isolate G. I could distribute by getting rid of Chewbacca, but I'm going to be more efficient because I'm going to get rid of that 7, which is adding to it, by subtracting. That gives me 3 times the quantity 2G minus 6 equals negative 36. Then I'm going to divide by 3. Now Chewbacca is gone. And negative 36 divided by 3 is negative 12. And now it's a two-step problem. I'm going to get rid of addition and subtraction. And then I'm going to get rid of the multiplication. And that gives me negative 3. Number 13, woo, look at all that stuff. Now, before I got rid of the addition and subtraction, well, I should notice that I have two variables in this problem. One is inside Chewbacca, the other one's outside. So I have to actually distribute first in order to simplify this problem. So noticing each of those little nuances and the differences is going to be really important on how you attack the problem. When you look at a problem, you want to see, how am I going to attack it? How am I going to, can I combine like terms? Can I combine like variables? How do I get rid of Chewbacca? So I'm going to multiply 0.6 times 12, which will give me 7.2. And then I'm going to distribute the 0.6 to negative 3n, which gives me negative 1.8n. Now I can combine like terms because Chewbacca's gone. I can combine these like terms because they're on the same side of the equal sign also. 25.8, 1.2n and negative 1.8n is negative 0.6n plus 7.2. I'm going to get rid of the 7.2. And that's going to give me 1. That's going to give me 8. And that's going to give me 6, I think. And negative 0.6n. And we're going to divide. Did I ever do that right? Yeah, 7, 14, 15. Yep, that's good. Divide by negative 0.6. And, well, we're going to use the calculator. We shouldn't necessarily be afraid of using the calculator. Divided by 0.6 gives me 31. Negative 31 equals n. Now, if that was a repeating decimal or something, I may just keep it as a fraction and convert it to an acceptable fraction. Number 14 says find 3 consecutive odd integers that have a sum of 63. So my first, I don't know any of these. I just know it's going to be 3 numbers that are odd integers. So, you know, something like 3, 5, and 7. Those are 3 consecutive odd integers. And if this is my first unknown, we know that my second one is going to be 2 away. And my third one is going to be 4 away from my original number. So I don't know what my first number is. So I can give that n. And I know that my next odd number in the sequence is going to be +2 from my first unknown. And if I want to find the third number, it's going to be 4 away from my first number. So the first number is n, the second number is n plus 2, and the third number is going to be n plus 4. So knowing that, I know that the sum of them, so n plus 2 plus n plus 4, this is my first number, this is my second number, and this is my third number. I know that the sum of those three numbers, consecutive odd numbers, is going to equal 63. So, ooh, I didn't want to do that. That was a bad thing. That's okay. That should probably be right there. That's probably better. I wanted to make these a little bit smaller. Can I do that? No. Okay, let's do this. Okay, we can utilize it. Hold on, be patient. Sorry, group. I just want to make that a little bit smaller. And now I'll move that thing back. That needs to go right there. That's good alignment. And then we're going to take this and we're going to move it over there. I just didn't want this equation when I'm solving this equation. Okay, back to this equation. So left side, we can combine like terms. We have those n's in there. So that gives me 3n, and the constants, 2 and 4 make 6, equals 63. We're going to subtract 6. We get 3n equals 57. We're going to divide by 3, and n equals 57 divided by 3 gives me 19. So n is 19. So n equals 19. So my next one is going to be 19 plus 2, which is 21. And this is going to be 19 plus 4, which is 23. So my three consecutive odd integers are going to be, where am I going to put this answer? Let's put it in green. It's going to be 19, 21, and 23. If we add those three digits up, it equals 63. Pretty cool, huh? All right, number 15. We can look proportionally. I'm always going to do, I'm going to do cross product just so we can stay consistent. I know that equivalent fractions, the product of their numbers across, 9 times x equals 5 times 63. The cross products will also be equal. 9x equals 5 times 63. 5 times 63 gives me 315. 315, I know that 9 goes into 315 because 3 plus 1 plus 5 gives me 9. So x, I know it's divisible. It's not that answer, but we're going to take 315 and we're going to divide it by 9, which equals 35. Good. Let's look at the next fraction, equivalent fraction. We're going to do the cross product. Cross product is going to be 9 times m equals 3 times 2. 2, I was already doing the math in my head. 9m equals 6. Divide by 9. M equals 6/9. We cannot leave that as the answer. This can be reduced. So I must simplify that fraction. My answer is going to be 2/3. You cannot leave it as 6/9. You must reduce all fractions. Alrighty. The next one, the right triangles created by each object and its shadow are similar. The height of a person is 5 feet 9 inches. Okay, we've got this person who is 5 feet 9 inches. And their shadow is 5 feet. So they project a shadow that is going to be 5 feet. We like that. That's a good problem. And if a totem pole has a shadow of 40 feet, so we have this totem pole, And typically there's like bird wings and I don't know. What else would be on there? Maybe some, I don't know. An eagle, right? You get a little face and I don't know, you get a couple more things. That's a pretty good totem pole. So I don't know how tall the totem pole is, but I do know that its shadow is 40 feet. Okay, so we may run out of space here on this problem, but has a shadow. What is its height? So we want to know. So the first thing we're going to do is we're going to write a fraction, and we're going to write 5 feet 9 inches is to 5 feet shadow, as I don't know what the height is to the shadow of the totem pole. So this is the height of the objects, and the bottom one is the shadow of the objects. And 5 foot 9 and 5 deal with the human, and X and 40 deal with the totem. Now, we want a cross product. We want to do that cross product, but we notice that we're in feet, inches, and feet. So we got to convert everything to the same. So what is 5 feet 9 inches? That's going to be 69 inches. 5 feet is going to be 60 inches equals X. 40 feet is going to be 480 inches. Did all that in my head. Now we can cross product because we're in all the same units, and we're going to solve it. So we have 69 times 480, 69 times 480, 33,120. Well, let's do this. 69. That's where we're going to write this. 69 times 480 equals 60 times X. And 69, 480 is 33,120. 33,120 equals 60X. Let's divide by 60. Divide by 60. So let's take that, divide it by 60, and we get 552. So X equals 552. 552 what? Inches. Now if we want to convert that to feet, we're going to divide that by 12 because there are 12 inches in every foot, and we get 46 feet. So I'm okay with either one. So the correct answer is going to be either 552 inches or 46 feet. Let's look at 18. 18, we're going to convert 0.6 kilograms to milligrams. So we have to remember this little mnemonic memory aid. King Hector died, unfortunately, drinking chocolate milk. And so we're talking about, when we look at this, we're dealing with kilo, hecto, deca, units, which is grams in this case, deci, centi, milli. So that is a nice, easy way, and we're going to go from kilo to this M. Now, this unit is G. This M in this case is milli. So how many decimal places do we have to go to get to milli? Starting at kilo. 1, 2, 3, 4, 5, 6. So we're going to move this decimal place, that decimal place, 6 places to the right. So 0.6, if we move it 6 places to the right, 1, 2, 3, 4, 5, 6. That's where the new decimal place is. And we're going to plop in some zeros in there, and we would get 600,000 milligrams. 0.6 kilograms is equivalent to 600,000 milligrams. Okay, that's how you do it. 1, 2, 3, 4, 5, 6 places. Yes. All right. A mako shark can swim up to about 19.5 meters per second. A bluefin tuna can swim up to 72.5 kilometers per hour. which animal has a greater swimming speed. So we have to make these the same. So I'm either going to change them to meters per second, or I'm going to change them both to kilometers per hour. I tend to go down to the smaller unit. So I'm going to convert 72 kilometers per hour to meters per second. So I'm going to start with this 72.5 meters, kilometers per 1 hour, and I'm going to change it to meters per second. That to me is going to be easier. So I'm going to choose, what do I want to convert first? Well, I think I'm going to convert my hours to seconds. So I have to write a conversion box. So my first conversion box is going to get rid of the hours. Can I go hours to seconds? No, I don't know how many seconds are an hour, but I do know hours to minutes. So if I want to cancel this hour in the denominator, my conversion box needs an hour in the numerator, because that's how they're going to cancel. So I'm going to go hour to minutes first. And I know 1 hour is equivalent to 60 minutes. So I am currently out of hours and I'm in minutes. So I'm going to write another conversion box in order to get out from minutes to seconds. So my minutes is in the denominator. If I want to get rid of it, I need to write minutes in the numerator in my other. And then I do know how many seconds are in a minute. I know 1 minute comprises of 60 seconds. So now I've canceled my minutes and I'm in seconds, and that's what I want to be in. That's my final unit that I want to get into. Okay, so I'm good with my time, and now I need a conversion to go from kilometers to meters. So kilometers starts in the numerator, so if I want to get rid of it, I'm going to put it in the denominator, and I know how many meters are in a kilometer. I know 1 kilometer is equivalent to 1,000 meters, and I see that I've canceled, and I'm in my final number. So this is all good. I may need to erase this, no, I don't want it red. Meters per second, so we can have, all right, now I can multiply these numbers. I could definitely multiply 72.5 times 1 times 1 times 1,000, and I can multiply the 1 here, the 60, and the 1, and I can get a value, and then I would have to convert it to a unit rate, because I want per second, per 1 second. But I'm going to look to get these numbers a little bit smaller. I'm going to see if I can cross cancel some other stuff. So I have a 0 here. I can cancel with the 0 here. I have a 0 here that I can cancel with the 0 there. I have a 6 and a 10. 2 goes in the 10 and 6. So 10 becomes 5. 6 becomes 3. What am I left with? That's about it. So I have the 5. And now I have 72.5. So let's do that. 72.5 times 5 gives me 362.5, 362.5 meters. And in my denominator, I have 1, 6, and 3 and 1, which makes 18. So I know that the bluefin can swim 362.5 meters for every 18 seconds. But that doesn't help me, because I'm kind of still, I don't know how fast this mako shark can swim in 18 seconds. I know how long or how fast how many meters it can swim in 1 second. So I'm going to change this to a unit. It's not the writing implement I want. I'm going to look for a unit rate, meaning per 1 second. So I'm going to take the 362.5 and I'm going to divide it by 18. And that gives me 20.138 repeating. 20.138 0.183 repeating meters per every second. That's how fast the tuna can swim. So how does that compare to the mako that can swim 19.5 meters per second? Well, when I'm comparing speed, I want something that travels faster per second or a farther distance per second. So which one swims faster? The bluefin swims faster. The bluefin swims faster because it can swim 20.183 repeating meters per second, where the mako can only swim 19.5 meters per second. That's pretty fast. I don't think I want to be in the water when either of them is coming after me. Last one, you use a tape measure to measure the dimensions of an aquarium. Okay, so I have an aquarium. An aquarium kind of looks like this, speaking of fishes. Hope that mako shark's not in there. So we have an aquarium. Let's make it blue. So there's my aquarium with water and fishies and everything good to go. Okay, so we've got this aquarium. You use a tape measure to measure the dimensions of an aquarium. The length is 17.7. Let's start putting that in. Mr. Mac is a concrete 17.7 inches. The width is 10.6 inches. And the height is 11.8 inches. Estimate the volume of the aquarium. All right, so a couple things. First of all, key word here, estimate. So I don't have to deal with these decimals per se. But the first thing I want to do is when I find the volume of a rectangular prism, volume is going to equal big B times H, where big B is equal to the area of the base. And H is the height of the object. The object or from the base. So I will tell you that the height of the object, as we talked about, was 11.8 inches. So that's going to be my H. The base area, if I have to find the area of the base is going to be the bottom of this container. It's going to be the bottom part. So I have to find the area of my base. That is down here. This is the base of the tank, and I have to find the area. The shape of that area is a rectangle. So this is going to be a rectangle. How do I find the area of a rectangle? Area of the rectangle is length times width. That goes in there. And the height. So length times width. I'm going to start creating some estimated distances. 17.7, I'm going to make 18 inches. 10.6, I'm going to keep it 10 for easy purposes. 11.8, let's do this. Let's change that to 20 inches. Let's change this to 10 inches because we can estimate. We've got some flexibility here. And I want to be able to not have to use a calculator. So we'll use those values. Everybody okay with that? Good. So hold on, this is going to be my base area. Area of the base. H is the height of the object. That's the distance between the two bases. So the length, I'm going to plug in. So I'm going to start plugging in. So the length is 20 inches times the width, which is 10 inches, those are my estimated values, times the height, which is also 10 inches. So now I'm going to multiply. I'm going to do what's inside the parentheses. 20 inches times 10 inches is 200 inches squared. And I'm going to multiply that value by 10 inches. So 200 inches squared times 10 inches. 200 times 10 is 2,000. And don't forget to do inches squared times inches, which gives me inches cubed. So my estimated value is 2,000. What you can't do, if we use the original values, let's do that out with the original values. So we would take the length, which is 17.7, we would multiply that by 10.6. That would be the area of my base. And then we're going to multiply that by the height, which was 11.8. And we get that number, which is close to my 2,000. That's very reasonable. But what we need to understand is if we were going to estimate that value, the most accurate I could get, or the number that I could provide, this is the actual value. No, let's do that. So this is the actual, this is the estimated. The best answer, I cannot give this answer. Not acceptable. I cannot give that answer. This is way too accurate for what I started with. The information that I was provided went out to the tenths place. So my answer can be no more accurate than the tenths place. So I can look at the tenths place and I can look to see how I want to round it. I'm going to keep the 9. So the best answer that I could possibly give is this. I could also give this answer. That's fine. That's rounded to the ones place. But I'm only going to the most accurate place that I can go out to is the tenths place. So this answer is okay. This answer is okay. 2,000 is okay. All of those 3 answers are okay. And you would need inches cubed, inches cubed, inches cubed, because we're dealing with volume and I'd want that unit. So hopefully you understand that it doesn't matter what you estimate that value to, but you can never get more specific than the place value, your most accurate place value that you're provided. Okay, so I hope that helps you. Those are the answer keys. I got to check that, make sure that those are correct, that those coincide. But I'll always provide you this video so you can study while you're at home. Hope this helps. Have a great one. Good luck with the assessment.